The theme of today's meeting was collaboration, and we've picked a subject for this session, which is electric vehicles. How can we collaborate to make and optimize electric vehicle design? I'm delighted to have three expert speakers as part of this session, and we're going to present perspectives on EV. And the brief was to see how we can be different and better with the UK membership that we have within AESIN. So I hope you'll find it interesting and stimulating. Let me first introduce this group. It's new this year. It's a special interest group which we've called Power Electronics and Control Systems. So it covers everything from the semiconductors through to the control systems and the vehicles themselves. So the brief is really to try and bring together participants from this community and outside. So if you're any of these, you are very welcome to join in this group. We're particularly looking for OEMs and their supply chains, research programs, regulatory organizations. We know that this is not new. There's an organization called Power Electronics UK, which has been around for many, many years. And of course, AESIN itself sprung from TechWorks, whose roots were in semiconductor and power electronics. But we really want to pull together the threads to focus particularly on hybrid and electric vehicles and how these components are used. We know that there are common issues of design, manufacture, industry awareness, which I hope you'll find interesting and we can work on together. Earlier today, the megatrends were mentioned. I've heard them called CASE, ACES, Connected, Autonomous, Shared Electrification. So 5 years ago, that was the trend. But with electric vehicles, it's migrated slightly. And if you talk to the younger generation who are buying cars, they care less really about the cars on the edge of this room. Gunny mentioned the 6-litre engine in this vehicle over here, I think it was. People buying cars today are actually less interested in that. They just want to get from A to B safely, reliably, efficiently, cheaply. And some of the mega trends are to do now with emissions reduction, saving the planet, reducing the nitrous oxides, reducing the CO2 emissions. There's a mega trend around powertrain development and control. Many of you are involved in this business, and we're going to talk about that a little bit. There's a big mega trend that I'm involved in my professional life on semiconductor innovation. The company I work for, Silvaco, innovates with semiconductor and compound semiconductor materials. So we're going to build that in a little bit. And very important, sustainability and reliability. How do we prevent destroying the planet in the process? So the application areas specifically, power electronics, of course, machines and drives, battery management systems, BMS ECUs, converters and inverters, AC to DC, DC to AC, and every other permutation. Onboard chargers for vehicles, vehicle networks. We work very closely with the software-defined vehicle group. I was heavily involved in that last year. And the combination of SDV and power electronics is really important. Many of you are involved in test and homologation. We want to roll that into this process and manage the overall life cycle with the right tools, digital twins, and processes. I already know some of you are involved in these areas. Battery management systems, Protean build electric motors into the wheel of the vehicle. That's an exciting innovation area. Power inverters. Many of you in the room I've spoken to are designing and developing ever more efficient energy converters. We don't have many indigenous battery manufacturers in the UK. We're dependent on offshore batteries, but maybe that's an area for innovation. And of course, onboard chargers to manage the vehicle power quota. Specifically, when we look at semiconductors, there's a lot of innovation going on in this area. Many of you will be aware of wide bandgap semiconductors, which have higher breakdown voltage. So silicon carbide already widely deployed in inverter design. But gallium nitride is taking over. It has better electrical characteristics in terms of switching speed, in terms of lower conductivity. That means lower energy loss in the inverter. It can also be smaller and lighter very important. So the graph in the middle shows some of the different materials used for the electronic switches in the inverters. And the graph continues to the right. So people now looking at gallium oxide as a compound semiconductor. Diamond has an even higher breakdown voltage. So you can then run your vehicle at a higher voltage, improve the efficiency even more. Thermal performance is very important. How quickly can you extract heat from a power inverter? So efficient cooling systems, and silicon carbide actually does well here. It has high thermal conductivity, so you can extract heat energy from the vehicle. But best of all, you don't create heat in the first place because it's lost energy. And every watt of power you can save means your car will go a little bit further. So these are the areas of research we're interested in looking at. We're also trying to optimize manufacturability, reliability. What are the aging effects of some of these new compounds? Will they age gracefully, or will it suddenly fail after 5 years? Car makers are building vehicles for a 20-year lifespan. So these become important topics as well. So I'm not going to say any more. I hope that gave you some context of the subject matter that we're interested in with this special interest group. Do contact me or Gunny if you'd like to be part of this going forward. We're looking for contributions and membership. Our output will be papers, documents, case studies, and most important, collaboration between members.